waveform graph. Do these write on this stuff?
We can find out.
I think it does.
I remember from back in the
so-
first grade.
Oh yeah, we used them for fix-its.
All right, so let's say that this is equilibrium, and that was where my, oh shoot, you don't see anything.
Try a
Oh,
Better,
that doesn't.
worse,
try a dark. Give a
better,
It's
oh
getting better.
ooh.
better.
That is nice.
Is that good?
That is nice.
You
All
sound
right.
like Night Doctor.
And we can sort of see, yes? All right. Now, if I then took another graph, and I guess I can do it here. All right, so let's say that this graph here, okay, I'm going to stick him up there, okay? So this graph here was at t equals 3 seconds. All right, and this is waveform, and this is vibration.
So what's the difference?
So 1, 2, so 0, 1, 2, 3. So that point right there is at 3 seconds. Okay? Now, I probably should have just gone to the machine instead of done this, but it made sense at the time. All right. Now, according to the vibration graph, what is the next thing that object is going to do? If this over here was 1 second, 2 seconds, 3 seconds, then the next thing it does is it vibrates up to a crest, then down through equilibrium, down to a trough, and then back up through equilibrium. Is that true?
Yes.
Okay.
Yep.
That's what the vibration graph does. This is the vibration graph of, let's call this guy P. So this is the vibration graph of P. And it tells you what P is doing all the time. All right? So, the vibration graph of P says that the next thing P does after 3 seconds is to vibrate up. So now take this waveform graph and decide where does this machine sit so that the next thing that happens is it vibrates up.
Well, it's going
Well,
down.
P can't move. P can't move. P just vibrates, right? You saw that. P doesn't move left and right. P just vibrates. Are you in agreement? We saw that, yes?
Mhm.
All right. So, if I want P to just vibrate, I have to move the wave through P's position. So to vibrate up, I need this crest right here to move that direction. Does that make sense? The wave is what's moving. So that means that the source would be over here and the wave direction is to the right. So we'll do it one more time. Alright? Okay, so start back again. This waveform graph is at a certain moment in time. At 3 seconds, this object you saw here was located at equilibrium. This vibration graph tells us how P vibrates over a longer period of time. Two totally different graphs. This graph up here has meters as its x-axis. This graph down here has seconds as its x-axis. They're two totally different events. Waveform, 1 moment in time. Vibration graph over a long period of time. So, at exactly 3 seconds when you took the picture of the waveform graph, it was right here at equilibrium. When I look at a different record of its behavior, I see that at 3 seconds, the next thing it's going to do is go up to a crest, back through equilibrium, down to a trough, back up through equilibrium. So it's going to vibrate up. The only way P can vibrate up is if I move the graph, so I move the wave so that a crest reaches P's location. So here is the nearest crest. In order for P to go up, I got to move that crest over. When I move that crest over, the next thing that approaches is a equilibrium. If it continues moving, then P goes into equilibrium. If it continues moving, then P goes into a trough, which is exactly what that little vibration graph says should happen. All right? So a waveform graph is one moment in time looking at a position. A vibration graph tells you what happens at that position over long periods of time. You use the vibration graph at the time the picture was taken to decide which way the wave is moving. So, at the time the picture was taken, 3 seconds, P was in equilibrium. The vibration graph says it has to vibrate up into a crest. You come back to the waveform, you see where's the nearest crest. The nearest crest is to the left, so therefore the wave must move to the right with the source on the left. Yes, no?
Okay, so
Okay.
the blue one is showing that item that we saw, and
Yes.
the other one is showing whether it's
The
going
green
up or
one,
down.
the green one is showing this.
Oh,
Okay, the top one is showing this.
what's-
So,
Waveform graph.
but the blue one is showing. Is it showing that like item?
right, the green one is showing what happens as time goes by.
I thought you said M was on the x-axis though.
What, dear?
The
I
meter.
can't do it. I'm left, right, right,
You
yes.
said that the x-axis is M,
The x-axis is meters on this one.
but it's still as time goes by.
Well, I can create this into a vibration graph, but its purpose is to show you a waveform graph.
So what's on the y-axis?
So what's on the y-axis is amplitude.
Okay, so amplitude per meter traveled.
Amplitude of energy of wave. Amplitude, how big it waves. So on this particular, when you see the images of the screen, of the spring, up here, this is a crest. Down here, this is a trough.
So
And through the center is equilibrium.
a waveform graph is actually what the
Wave looks like it. What if you took a camera out and said, bam, right now I'm taking a picture of what this looks like.
Okay.
So
And then the
it's
vibration
static,
graph
right?
is
It's
telling
showing you how it
what it's
vibrates
doing.
over the piece of time.
So,
Okay.
and this is not a wave that moves like a wave.
No, this is a wave that moves like through the water
Okay.
or something. All right?
Okay.
This is a wave that lets this object bounce. So what I'm trying to say to you is when we had this stretched, and a point that, okay, where's the kink in it? Okay, so this kink right here, all right? This kink doesn't go left and right. If I'm sending the wave energy to Sarah, all right, and we're looking just at this kink right here, all the kink does is vibrate back and forth. Yes? The kink doesn't go towards Sarah or towards me. The kink just vibrates back and forth, right?
On the z-axis or something?
Well, I don't know. You want to call this X?
Yeah.
Call this Y?
Mhm.
So it's vibrating on the Y-axis. All right? So notice you can even see it as you watch it because it sort of has, there's, right in here is where the kink is. Yes? So what's the kink doing? It's just going up and down like this, correct? So I'm the source, Sarah's the reflector, right?
Yeah.
So what's happening is, because of this waveform that I created, all right, you can see that this object is moving just back and forth at its given location. That's what this spring is supposed to show you.
Okay.
That the point just moves back and forth at its location.
So then,
right?
what's the vibration?
The vibration graph would be something we don't have at the moment, but I think I have some string in here.
Yeah, there's
All right.
scissors right there.
Um,
Or you can, I think you can just pull it. Oh, never mind, don't pull it.
There it is. That's better. Okay. Now, the vibration graph would be if we had a card in here, and maybe the card would be in here, and we had a motion detector just watching that card.
Okay.
What's this object doing as time goes by?
Moving back
Okay,
and forth.
it's moving back and forth. So it would show the vibration occurring.
Okay.
All right? What the waveform graph is saying is, okay, I'm going to send a curve, and at this instant in time, my point that I care to look at is up here.
Okay.
Okay, vibration is going to show you what happens to this point over 10
It's
seconds.
like position
The
versus
waveform graph just says, bam, at exactly 3 seconds I'm going to take that picture
time.
and see what it looks like.
Okay.
All right? Another way to think of it, yes, Sarah's really entranced with this. Probably ought to cut it off. All right, now, what you could do is you could think of it, instead of springs, you could think of it as a buoy in water and you're on the boardwalk. You're on a pier, all right? So a set of waves is coming in. And that buoy is responding to the waves. So it's going up and down and up and down and up and down, all right? So you take your camera out, all right? And at some moment in time, you take a picture of the buoy just for the sake of taking it. I have to watch my language here, all right? For the sake of taking it, all right? And at that instant in time, it was, 4:28:36, whatever. It was some time on the clock, all right? Now, somebody else is interested in that same buoy, but they're doing a totally different activity. What they're doing is they're just watching the buoy, and they're just recording what the buoy's doing, all right? So their x-axis is time. Your x-axis is the whole panorama of the beach, okay? So, according to their time x-axis, you could tell where the source was, all right? Because if it's going to go up, then the source has to be in such a position that it pushes a crest to it. If the next thing it does is go down, the source has to be in a position to push a trough to it. Okay? Good? All right. So now we're going to look at a worksheet while I set the other lab up. All right? And the worksheet is called Waveform and Vibration Graphs. And I think at this time you could probably stop the video and let